Overview. This chapter introduces you to Java EE Enterprise Application Development. Here you will review development basics, learn about the Java EE architecture and APIs, become acquainted with important terms and concepts, and find out how to approach Java EE application programming, assembly, and deployment. Developers today increasingly recognize the need for distributed, transactional, and portable applications that leverage the speed, security, and reliability of server-side technology. Enterprise applications provide the business logic for an enterprise. They are centrally managed and often interact with other enterprise software. In the world of information technology, enterprise applications must be designed, built, and produced for less money, with greater speed, and with fewer resources. With the Java Platform, Enterprise Edition Java EE, development of Java enterprise applications has never been easier or faster. The aim of the Java EE platform is to provide developers with a powerful set of APIs while shortening development time, reducing application complexity, and improving application performance. The Java EE platform is developed through the Java Community Process JACP, which is responsible for all Java technologies. Expert groups composed of interested parties have created Java specification requests JSRs to define the various Java EE technologies. The work of the Java community under the JCP program helps to ensure Java technologies standards of stability and cross-platform compatibility. The Java EE platform uses a simplified programming model. XML deployment descriptors are optional. Instead, a developer can simply enter the information as an annotation directly into a Java source file, and the Java EE server will configure the component at deployment and runtime. These annotations are generally used to embed in a program data that would otherwise be furnished in a deployment descriptor. With annotations, you put the specification information in your code next to the program element affected. In the Java EE platform, dependency injection can be applied to all resources a component needs, effectively hiding the creation and lookup of resources from application code. Dependency injection can be used in enterprise JavaBeans EJB containers, web containers, and application clients. Dependency injection allows the Java EE container to automatically insert references to other required components or resources, using annotations. This tutorial uses examples to describe the features available in the Java EE platform for developing enterprise applications. Whether you are a new or experienced enterprise developer, you should find the examples and accompanying text a valuable and accessible knowledge base for creating your own solutions. The following topics are addressed here: Java EE 7 platform highlights, Java EE application model, distributed multi-tiered applications, Java EE containers, web services support, Java EE application assembly and deployment, Java EE 7 APIs, Java EE 7 APIs, in the Java platform, Standard Edition 7, Glassfish Server Tools, Java EE 7 platform highlights. The most important goal of the Java EE 7 platform is to simplify development by providing a common foundation for the various kinds of components in the Java EE platform. Developers benefit from productivity improvements with more annotations and less XML configuration, more plain old Java objects POJOs, and simplified packaging. The Java EE 7 platform includes the following new features. New technologies, including the following: O-Batch applications for the Java platform, O-Concurrency utilities for Java EE, O-Java API for JSON processing JSONP, O-Java API for WebSocket. New features for EJB components. See Enterprise JavaBeans technology for details. New features for servlet. See Java Servlet technology for details. New features for Java Server Faces components. See Java Server Faces technology for details. New features for the Java Message Service JMS. See Java Message Service API for details. Java EE application model. The Java EE application model begins with the Java programming language and the Java virtual machine. The proven portability, security, and developer productivity they provide form the basis of the application model. Java EE is designed to support applications that implement enterprise services for customers, employees, suppliers, partners, and others who make demands on or contributions to the enterprise. Such applications are inherently complex, potentially accessing data from a variety of sources and distributing applications to a variety of clients. To better control and manage these applications, the business functions to support these various users are conducted in the middle tier. The middle tier represents an environment that is closely controlled by an enterprise's information technology department. The middle tier is typically run on dedicated server hardware and has access to the full services of the enterprise. The Java EE application model defines an architecture for implementing services as multi-tier applications that deliver the scalability, accessibility, and manageability needed by enterprise-level applications. This model partitions the work needed to implement a multi-tier service into the following parts. The business and presentation logic to be implemented by the developer. The standard system services provided by the Java EE platform. The developer can rely on the platform to provide solutions for the hard systems level problems of developing a multi-tier service. Distributed multi-tiered applications. The Java EE platform uses a distributed multi-tiered application model for enterprise applications. Application logic is divided into components according to function, and the application components that make up a Java EE application are installed on various machines depending on the tier in the multi-tiered Java EE environment to which the application component belongs. Figure 1-1 shows two multi-tiered Java EE applications divided into the tiers described in the following list. The Java EE application parts shown in Figure 1-1 are presented in Java EE components. Client tier components run on the client machine. Web tier components run on the Java EE server. Business tier components run on the Java EE server. Enterprise Information System EIS tier software runs on the EIS server. Although a Java EE application can consist of all tiers shown in Figure 1-1, Java EE multi-tiered applications are generally considered to be three-tiered applications because they are distributed over three locations. Client machines, the Java EE server machine, and the database or legacy machines at the back end. Three-tiered applications that run in this way extend the standard two-tiered client and server model by placing a multi-threaded application server between the client application and back-end storage. Figure 1-1 multi-tiered applications. Description of Figure 1-1 multi-tiered applications. Security. Although other enterprise application models require platform-specific security measures in each application, the Java EE security environment enables security constraints to be defined at deployment time. The Java EE platform makes applications portable to a wide variety of security implementations by shielding application developers from the complexity of implementing security features. The Java EE platform provides standard declarative access control rules that are defined by the developer and interpreted when the application is deployed on the server. Java EE also provides standard login mechanisms so that application developers do not have to implement these mechanisms in their applications. The same application works in a variety of security environments without changing the source code. Java EE components. Java EE applications are made up of components. A Java EE component is a self-contained functional software unit that is assembled into a Java EE application with its related classes and files and that communicates with other components. The Java EE specification defines the following Java EE components. Application clients and applets are components that run on the client. Java servlet, Java server faces, and Java server pages JACP technology components are web components that run on the server. EJB components enterprise beans are business components that run on the server. Java EE components are written in the Java programming language and are compiled in the same way as any program in the language. The differences between Java EE components and standard Java classes are that Java EE components are assembled into a Java EE application, they are verified to be well-formed and in compliance with the Java EE specification, and they are deployed to production, where they are run and managed by the Java EE server. Java EE clients. A Java EE client is usually either a web client or an application client. Web clients. A web client consists of two parts. Dynamic web pages containing various types of markup language HTML, XML, and so on, which are generated by web components running in the web tier. A web browser, which renders the pages received from the server. A web client is sometimes called a thin client. Thin clients usually do not query databases, execute complex business rules, or connect to legacy applications. When you use a thin client, such heavyweight operations are offloaded to enterprise beans executing on the Java EA server, where they can leverage the security, speed, services, and reliability of Java EA server-side technologies. Application clients. An application client runs on a client machine and provides a way for users to handle tasks that require a richer user interface than can be provided by a markup language. An application client typically has a graphical user interface GUI created from the Swing API or the Abstract Window Toolkit AutoAPI, but a command line interface is certainly possible. Application clients directly access enterprise beans running in the business tier. However, if application requirements warrant it, an application client can open an HTTP connection to establish communication with a servlet running in the web tier. Application clients written in languages other than Java can interact with Java EA servers, enabling the Java EA platform to interoperate with legacy systems, clients, and non-Java languages. Applets. A web page received from the web tier can include an embedded applet. Written in the Java programming language, an applet is a small client application that executes in the Java virtual machine installed in the web browser. However, client systems will likely need the Java plugin and possibly a security policy file for the applet to successfully execute on the web browser. Web components are the preferred API for creating a web client program because no plugins or security policy files are needed on the client systems. Also, web components enable cleaner and more modular application design because they provide a way to separate applications programming from web page design. Personnel involved in web page design thus do not need to understand Java programming language syntax to do their jobs. The JavaBeans component architecture. The server and client tiers might also include components based on the JavaBeans component architecture. JavaBeans components to manage the data flow between the following: an application client or applet and components running on the Java EA server, server components in a database. JavaBeans components are not considered Java EA components by the Java EA specification. JavaBeans components have properties and have get and set methods for accessing those properties. JavaBeans components used in this way are typically simple in design and implementation but should conform to the naming and design conventions outlined in the JavaBeans component architecture. Java EA Server Communications. Figure 1-2 shows the various elements that can make up the client tier. The client communicates with a business tier running on the Java EA server either directly or, as in the case of a client running in a browser, by going through web pages or servlets running in the web tier. Figure 1-2 Server Communication. Description of Figure 1-2 Server Communication Web Components. Java EA web components are either servlets or web pages created using Java Server Faces technology or JSP technology. JSP pages. Servlets are Java programming language classes that dynamically process requests and construct responses. JSP pages are text-based documents that execute as servlets but allow a more natural approach to creating static content. Java Server Faces technology builds on servlets and JSP technology and provides a user interface component framework for web applications. Static HTML pages and applets are bundled with web components during application assembly but are not considered web components by the Java EA specification. Server-side utility classes can also be bundled with web components and, like HTML pages, are not considered web components. As shown in Figure 1-3, the web tier, like the client tier, might include a JavaBeans component to manage the user input and send that input to enterprise beans running in the business tier for processing. Figure 1-3 Web tier and Java EA applications. Description of Figure 1-3 Web tier and Java EA applications. Business components. Business code, which is logic that solves or meets the needs of a particular business domain such as banking, retail, or finance, is handled by Enterprise Beans running in either the business tier or the web tier. Figure 1-4 shows how an Enterprise Bean receives data from client programs, processes it if necessary, and sends it to the Enterprise Information System tier for storage. An Enterprise Bean also retrieves data from storage, processes it if necessary, and sends it back to the client program. Figure 1-4 Business and EIS tiers. Description of Figure 1-4 Business and EIS tiers. Enterprise Information System tier. The Enterprise Information System tier handles EIS software and includes enterprise infrastructure systems, such as Enterprise Resource Planning ERP, mainframe transaction processing, database systems, and other legacy information systems. For example, Java EA application components might need access to enterprise information systems for database connectivity. Java EA containers. Normally, thin client multi-tiered applications are hard to write because they involve many lines of intricate code to handle transaction and state management, multi-threading, resource pooling, and other complex low-level details. The component-based and platform-independent Java EA architecture makes applications easy to write because business logic is organized into reusable components. In addition, the Java EA server provides underlying services in the form of a container for every component type. Because you do not have to develop these services yourself, you are free to concentrate on solving the business problem at hand. Container services. Containers are the interface between a component and the low-level, platform-specific functionality that supports the component. Before it can be executed, a web, Enterprise Bean, or application client component must be assembled into a Java EE module and deployed into its container. The assembly process involves specifying container settings for each component in the Java EE application and for the Java EE application itself. Container settings customize the underlying support provided by the Java EE server, including such services as security, transaction management, Java naming and directory interface JNDI API lookups, and remote connectivity. Here are some of the highlights. The Java EE security model lets you configure a web component or Enterprise Bean so that system resources are accessed only by authorized users. The Java EE transaction model lets you specify relationships among methods that make up a single transaction so that all methods in one transaction are treated as a single unit. JNDI lookup services provide a unified interface to multiple naming and directory services in the enterprise so that application components can access these services. The Java EE remote connectivity model manages low-level communications between clients and Enterprise Beans. After an Enterprise Bean is created, a client invokes methods on it as if it were in the same virtual machine. Because the Java EE architecture provides configurable services, components within the same application can behave differently based on where they are deployed. For example, an Enterprise Bean can have security settings that allow it a certain level of access to database data in one production environment and another level of database access in another production environment. The container also manages non-configurable services, such as Enterprise Bean and servlet lifecycles, database connection resource pooling, data persistence, and access to the Java EE platform APIs. See Java EE 7 APIs. Container types. The deployment process installs Java EE application components in the Java EE containers, as illustrated in Figure 1-5. Figure 1-5 Java EE Server and Containers. Description of Figure 1-5 Java EE Server and Containers. The server and containers are as follows. Java EE Server. The runtime portion of a Java EE product. A Java EE server provides EJB and web containers. EJB container manages the execution of Enterprise Beans for Java EE applications. Enterprise Beans and their container run on the Java EE server. Web container manages the execution of web pages, servlets, and some EJB components for Java EE applications. Web components and their container run on the Java EE server. Application client container manages the execution of application client components. Application clients and their container run on the client. Applet container manages the execution of applets. consists of a web browser and a Java plug-in running on the client together. Web services support. Web services are web-based enterprise applications that use open, XML-based standards and transport protocols to exchange data with calling clients. The Java EE platform provides the XML apps and tools you need to quickly design, develop, test, and deploy web services and clients that fully interoperate with other web services and clients running on Java-based or non-Java-based platforms. To write web services and clients with the Java EE XML apps, all you need to do is pass parameter data to the method calls and process the data returned. For document-oriented web services, you send documents containing the service data back and forth. No low-level programming is needed because the XML API implementations do the work of translating the application data to and from an XML-based data stream that is sent over the standardized XML-based transport protocols. These XML-based standards and protocols are introduced in the following sections. The translation of data to a standardized XML-based data stream is what makes web services and clients written with the Java EE XML apps fully interoperable. This does not necessarily mean that the data being transported includes XML tags, because the transported data can itself be plain text, XML data, or any kind of binary data, such as audio, video, maps, program files, computer-aided design CAD documents, and the like. The next section introduces XML and explains how parties doing business can use XML tags and schemas to exchange data in a meaningful way. XML Extensible Markup Language. XML is a cross-platform, extensible, text-based standard for representing data. Parties that exchange XML data can create their own tags to describe the data, set up schemas to specify which tags can be used in a particular kind of XML document, and use XML style sheets to manage the display and handling of the data. For example, a web service can use XML and a schema to produce price lists, and companies that receive the price lists and schema can have their own style sheets to handle the data in a way that best suits their needs. Here are examples. One company might put XML pricing information through a program to translate the XML into HTML so that it can post the price lists to its intranet. A partner company might put the XML pricing information through a tool to create a marketing presentation. Another company might read the XML pricing information into an application for processing. SOAP Transport Protocol. Client requests and web service responses are transmitted as simple Object Access Protocol SOAP messages over HTTP to enable a completely interoperable exchange between clients and web services, all running on different platforms and at various locations on the Internet. HTTP is a familiar request and response standard for sending messages over the Internet, and SOAP is an XML-based protocol that follows the HTTP request and response model. The SOAP portion of a transported message does the following. Defines an XML-based envelope to describe what is in the message and explain how to process the message. Includes XML-based encoding rules to express instances of application-defined data types within the message. Defines an XML-based convention for representing the request to the remote service and the resulting response. WSDL standard format. The web services description language WSDL is a standardized XML format for describing network services. The description includes the name of the service, the location of the service, and ways to communicate with the service. WSDL service descriptions can be published on the web. Glassfish Server provides a tool for generating the WSDL specification of a web service that uses remote procedure calls to communicate with clients. Java EE Application Assembly and Deployment. A Java EE application is packaged into one or more standard units for deployment to any Java EE platform-compliant system. Each unit contains a functional component or components, such as an enterprise bean, web page, servlet, or applet. An optional deployment descriptor that describes its content. Once a Java EE unit has been produced, it is ready to be deployed. Deployment typically involves using a platform's deployment tool to specify location-specific information, such as a list of local users who can access it and the name of the local database. Once deployed on a local platform, The application is ready to run. Java EA7 APIs. Figure 1-6 shows the relationships among the Java EA containers. Figure 1-6 Java EA containers. Description of Figure 1-6 Java EA containers. Figure 1-7 shows the availability of the Java EA7 APIs in the web container. Figure 1-7 Java EE APIs in the web container. Description of Figure 1-7 Java EE APIs in the web container. Figure 1-8 shows the availability of the Java EA7 APIs in the EJB container. Figure 1-8 Java EE APIs in the EJB container. Description of Figure 1-8 Java EE APIs in the EJB container. Figure 1-9 shows the availability of the Java EA7 APIs in the application client container. Figure 1-9 Java EE APIs in the application client container. Description of Figure 1-9 Java EE APIs in the application client container. The following sections give a brief summary of the technologies required by the Java EE platform and the APIs used in Java EE applications. Enterprise JavaBeans technology. An Enterprise JavaBeans EJB component, or Enterprise Bean, is a body of code that has fields and methods to implement modules of business logic. You can think of an Enterprise Bean as a building block that can be used alone or with other Enterprise Beans to execute business logic on the Java EE server. Enterprise beans are either session beans or message-driven beans. A session bean represents a transient conversation with the client. When the client finishes executing, the session bean and its data are gone. A message-driven bean combines features of a session bean and a message listener, allowing a business component to receive messages asynchronously. Commonly, these are Java Message Service JMS messages. In the Java EA7 platform, new Enterprise Bean features include the following: asynchronous local session beans in EJB Lite, non-persistent timers in EJB Lite. The Java EA7 platform requires Enterprise JavaBeans 3, 2 and interceptors 1, 2. The interceptor specification is part of the EJB specification, Java Servlet technology. Java Servlet technology lets you define HTTP-specific servlet classes. A servlet class extends the capabilities of servers that host applications accessed by way of a request-response programming model. Although servlets can respond to any type of request, they are commonly used to extend the applications hosted by web servers. In the Java EA7 platform, new Java Servlet technology features include the following: non-blocking I/O, HTTP protocol upgrade. The Java EA7 platform requires Servlet 3. 1. Java Server Faces technology. Java Server Faces technology is a user interface framework for building web applications. The main components of Java Server Faces technology are as follows: a GUI component framework, a flexible model for rendering components in different kinds of HTML or different markup languages and technologies. A renderer object generates the markup to render the component and converts the data stored in a model object to types that can be represented in a view. A standard render kit for generating HTML4. Markup. The following features support the GUI components: input validation, event handling, data conversion between model objects and components, managed model object creation, page navigation configuration, expression language EL. All this functionality is available using standard Java APIs and XML-based configuration files. In the Java EA7 platform, new features of Java Server Faces technology include the following: HTML5-friendly markup, faces flows, resource library contracts. The Java EA7 platform requires Java Server Faces 2, 2 and expression language 3. 0. Java Server Pages technology. Java Server Pages JAXP technology lets you put snippets of servlet code directly into a text-based document. A JAXP page is a text-based document that contains two types of text: static data, which can be expressed in any text-based format, such as HTML or XML. JAXP elements, which determine how the page constructs dynamic content. For information about JAXP technology, see the Java EE 5 tutorial at http://docs.oracle.com. Java EE 5 tutorial. Doc. The Java EE 7 platform requires Java Server Pages 2.3 for compatibility with earlier releases but recommends the use of facelets as the display technology in new applications. Java Server Pages Standard Tag Library. The Java Server Pages Standard Tag Library JSTL encapsulates core functionality common to many JAXP applications. Instead of mixing tags from numerous vendors in your JAXP applications, you use a single, standard set of tags. This standardization allows you to deploy your applications on any JAXP container that supports JSTL and makes it more likely that the implementation of the tags is optimized. JSTL has iterator and conditional tags for handling flow control, tags for manipulating XML documents, internationalization tags, tags for accessing databases using SQL, and tags for commonly used functions. The Java EE 7 platform requires JSTL 1.2 Java Persistence API. The Java Persistence API JPA is a Java standards-based solution for persistence. Persistence uses an object relational mapping approach to bridge the gap between an object-oriented model and a relational database. The Java Persistence API can also be used in Java SE applications outside of the Java EE environment. Java Persistence consists of the following areas. The Java Persistence API, the query language object. Relational mapping metadata. The Java EE 7 platform requires Java Persistence API 2.1 Java Transaction API. The Java Transaction API JTA provides a standard interface for demarcating transactions. The Java EE architecture provides a default auto-commit to handle transaction commits and rollbacks. An auto-commit means that any other applications that are viewing data will see the updated data after each database read or write operation. However, if your application performs two separate database access operations that depend on each other, you will want to use the JTA API to demarcate where the entire transaction, including both operations, begins, rolls back, and commits. The Java EE 7 platform requires Java Transaction API 1.2 Java API for RESTful Web Services. The Java API for RESTful Web Services JAXRS defines APIs for the development of web services built according to the representational state transfer REST architectural style. A JAXRS application is a web application that consists of classes packaged as a servlet in a WAR file along with required libraries. The Java EE 7 platform requires JAXRS 2.0 Managed Beans. Managed Beans, lightweight container managed objects POJOs with minimal requirements, support a small set of basic services, such as resource injection, lifecycle callbacks, and interceptors. Managed Beans represent a generalization of the Managed Beans specified by Java Server Faces technology and can be used anywhere in the Java EE application, not just in web modules. The Managed Beans specification is part of the Java EE 7 platform specification JSR 342. The Java EE 7 platform requires Managed Beans 1.0 Contexts and Dependency Injection for Java EE. Contexts and Dependency Injection for Java EE 401 defines a set of contextual services provided by Java EE containers that make it easy for developers to use Enterprise Beans along with Java Server Faces technology in web applications. Designed for use with stateful objects, 401 also has many broader uses, allowing developers a great deal of flexibility to integrate different kinds of components in a loosely coupled but type-safe way. The Java EE 7 platform requires 401 1. Dependency Injection for Java. Dependency injection for Java defines a standard set of annotations and one interface for use on injectable classes. In the Java EE platform, 401 provides support for dependency injection. Specifically, you can use injection points only in a 401-enabled application. The Java EA7 platform requires dependency injection for Java 1.0. Bean validation. The Bean validation specification defines a metadata model and API for validating data in JavaBeans components. Instead of distributing validation of data over several layers, such as the browser and the server side, you can define the validation constraints in one place and share them across the different layers. The Java EA7 platform requires Bean validation 1. Java Message Service API. The Java Message Service JAXP is a messaging standard that allows Java EA application components to create, send, receive, and read messages. It enables distributed communication that is loosely coupled, reliable, and asynchronous. In the platform, new features of JMS include the following. A new, simplified API offers a simpler alternative to the previous API. This API includes a context object that combines the functions of a connection and a session. All objects with a close method implement the Java lang autoclosable interface so that they can be used in a Java EA7 try with resources statement. The Java EA7 platform requires JMS 2.0 Java EA connector architecture. The Java EA connector architecture is used by tools vendors and system integrators to create resource adapters that support access to enterprise information systems that can be plugged into any Java EA product. A resource adapter is a software component that allows Java EA application components to access and interact with the underlying resource manager of the EIS. Because a resource adapter is specific to its resource manager, a different resource adapter typically exists for each type of database or enterprise information system. The Java EA connector architecture also provides a performance-oriented, secure, scalable, and message-based transactional integration of Java EA platform-based web services with existing EISs that can be either synchronous or asynchronous. Existing applications and EISs integrated through the Java EA connector architecture into the Java EA platform can be exposed as XML-based web services by using JAXWS and Java EA component models. Thus JAXWS and the Java EA connector architecture are complementary technologies for enterprise application integration EAI and end-to-end business integration. The Java EA7 platform requires Java EA connector architecture 1.7. Java Mail API. Java EA applications use the Java Mail API to send email notifications. The Java Mail API has two parts. An application-level interface used by the application components to send mail. A service provider interface. The Java EA platform includes the Java Mail API with a service provider that allows application components to send internet mail. The Java EA7 platform requires Java Mail 1.5. Java Authorization Contract for Containers. The Java Authorization Contract for Containers JACC specification defines a contract between the Java EA application server and an authorization policy provider. All Java EA containers support this contract. The JACC specification defines Java security permission classes that satisfy the Java EA authorization model. The specification defines the binding of container access decisions to operations on instances of these permission classes. It defines the semantics of policy providers that use the new permission classes to address the authorization requirements of the Java EA platform, including the definition and use of roles. The Java EA7 platform requires JACC 1.5. Java Authentication Service Provider Interface for Containers. The Java Authentication Service Provider Interface for Containers JACP specification defines a service provider interface SPI by which authentication providers that implement message authentication mechanisms may be integrated in client or server message processing containers or runtimes. Authentication providers integrated through this interface operate on network messages provided to them by their calling containers. The authentication providers transform outgoing messages so that the source of each message can be authenticated by the receiving container, and the recipient of the message can be authenticated by the message sender. Authentication providers authenticate each incoming message in return to their calling containers the identity established as a result of the message authentication. The Java EE7 platform requires JACP 1. Java API for WebSocket. WebSocket is an application protocol that provides full duplex communications between two peers over TCP. The Java API for WebSocket enables Java EE applications to create endpoints using annotations that specify the configuration parameters of the endpoint and designate its lifecycle callback methods. The WebSocket API is new to the Java EE7 platform. The Java EE7 platform requires Java API for WebSocket 1.0. Java API for JSON processing. JSON is a text-based data exchange format derived from JavaScript that is used in web services and other connected applications. The Java API for JSON processing JSONP enables Java EE applications to parse, transform, and query JSON data using the object model or the streaming model. JSONP is new to the Java EE7 platform. The Java EE7 platform requires JSONP 1.0. Concurrency utilities for Java EE. Concurrency utilities for Java EE is a standard API for providing asynchronous capabilities to Java EE application components through the following types of objects: Managed Executor Service, Managed Scheduled Executor Service, Managed Thread Factory, and Context Service. Concurrency utilities for Java EE is new to the Java EE7 platform. The Java EE7 platform requires concurrency utilities for Java EE 1.0. Batch applications for the Java platform. Batch jobs are tasks that can be executed without user interaction. The batch applications for the Java platform specification is a batch framework that provides support for creating and running batch jobs in Java applications. The batch framework consists of a batch runtime, a job specification language based on XML, a Java API to interact with the batch runtime, and a Java API to implement batch artifacts. Batch applications for the Java platform is new to the Java EE7 platform. The Java EE7 platform requires batch applications for the Java platform 1.0. Java EE7 APIs in the Java platform, Standard Edition 7. Several APIs that are required by the Java EE7 platform are included in the Java platform, Standard Edition 7 Java SE 7 and are thus available to Java EE applications. Java Database Connectivity API. The Java Database Connectivity JDBC API lets you invoke SQL commands from Java programming language methods. You use the JDBC API in an enterprise bean when you have a session bean access the database. You can also use the JDBC API from a servlet or a JAXP page to access the database directly without going through an enterprise bean. The JDBC API has two parts: an application-level interface used by the application components to access a database, a service provider interface to attach a JDBC driver to the Java EE platform. The Java SE 7 platform requires JDBC 4.1. Java Naming and Directory Interface API. The Java Naming and Directory Interface JNDI API provides naming and directory functionality, enabling applications to access multiple naming and directory services, such as LDAP, DNS, and NIS. The JNDI API provides applications with methods for performing standard directory operations, such as associating attributes with objects and searching for objects using their attributes. Using JNDI, a Java EE application can store and retrieve any type of named Java object, allowing Java EE applications to coexist with many legacy applications and systems. Java EE naming services provide application clients, enterprise beans, and web components with access to a JNDI naming environment. A naming environment allows a component to be customized without the need to access or change the component source code. A container implements the component's environment and provides it to the component as a JNDI naming context. The naming environment provides four logical namespaces: Java, Comp, Java, Module, Java, App, and Java. Global for objects available to components, modules, or applications or shared by all deployed applications. A Java EE component can access named system-provided and user-defined objects. The names of some system-provided objects, such as a default JDBC data source object, a default JMS connection factory, and a JTA user transaction object, are stored in the Java comp namespace. The Java EE platform allows the component to name user-defined objects, such as enterprise beans, environment entries, JDBC data source objects, and messaging destinations. A Java EE component can also locate its environment naming context by using JNDI interfaces. A component can create a JAVAX naming initial context object and look up the environment naming context in initial context under the name Java comp env. A component's naming environment is stored directly in the environment naming context or in any of its direct or indirect subcontexts. JavaBeans Activation Framework. The JavaBeans Activation Framework JAF is used by the Java Mail API. JAF provides standard services to determine the type of an arbitrary piece of data, encapsulate access to it, discover the operations available on it, and create the appropriate JavaBeans component to perform those operations. Java API for XML Processing. The Java API for XML Processing JAXP, part of the Java SE platform, supports the processing of XML documents using Document Object Model DOM, Simple API for XML SACS, and Extensible Style Sheet Language Transformations XSLT. JAXP enables applications to parse and transform XML documents independently of a particular XML processing implementation. JAXP also provides namespace support, which lets you work with schemas that might otherwise have naming conflicts. Designed to be flexible, JAXP lets you use any XML-compliant parser or XSL processor from within your application and supports the World Wide Web Consortium W3C schema. You can find information on the W3C schema at http://w3.org. XML schema. Java architecture for XML binding. The Java architecture for XML binding JAXP provides a convenient way to bind an XML schema to a representation in Java language programs. JAXP can be used independently or in combination with JAXWS, in which case it provides a standard data binding for web service messages. All Java EE application client containers, web containers, and EJB containers support the JAXP API. The Java EE7 platform requires JAXP 2. Java API for XML Web Services. The Java API for XML Web Services JAXWS specification provides support for web services that use the JAXP API for binding XML data to Java objects. The JAXWS specification defines client APIs for accessing web services as well as techniques for implementing web service endpoints. The Implementing Enterprise Web Services specification describes the deployment of JAXWS-based services and clients. The EJB and Java servlet specifications also describe aspects of such deployment. JAXWS-based applications can be deployed using any of these deployment models. The JAXWS specification describes the support for message handlers that can process message requests and responses. In general, these message handlers execute on the same container and with the same privileges and execution context as the JAXWS client or endpoint component with which they are associated. These message handlers have access to the same JNDI namespace as their associated component. Custom serializers and deserializers, if supported, are treated in the same way as message handlers. The Java EE7 platform requires JAXWS 2. SOAP with Attachments API for Java. The SOAP with Attachments API for Java SAAJ is a low-level API on which JAXWS depends. SAAJ enables the production and consumption of messages that conform to the SOAP 1 and 1.2 specifications and the SOAP with Attachments node. Most developers do not use the SAAP instead using the higher-level JAXP API. Java Authentication and Authorization Service. The Java Authentication and Authorization Service JAS provides a way for a Java EA application to authenticate and authorize a specific user or group of users to run it. JAS is a Java programming language version of the standard Pluggable Authentication Module (PAM) framework, which extends the Java platform security architecture to support user-based authorization. Common annotations for the Java platform. Annotations enable a declarative style of programming in the Java platform. The Java EA7 platform requires common annotations for the Java platform. 1. 2. Glassfish Server Tools. Glassfish Server is a compliant implementation of the Java EA7 platform. In addition to supporting all the APIs described in the previous sections, Glassfish Server includes a number of Java EA tools that are not part of the Java EA7 platform but are provided as a convenience to the developer. This section briefly summarizes the tools that make up Glassfish Server. Instructions for starting and stopping Glassfish Server, starting the administration console, and starting and stopping the Java DB server are in Chapter 2, using the tutorial examples. Glassfish Server contains the tools listed in Table 1-1. Basic usage information for many of the tools appears throughout the tutorial. For detailed information, see the online help in the GUI tools. Table 1-1 Glassfish Server Tools. An Administration Console. A web-based GUI Glassfish Server administration utility. Used to stop Glassfish Server and to manage users, resources, and applications. A sysadmin. A command-line Glassfish Server administration utility. Used to start and stop Glassfish Server and to manage users, resources, and applications. App Client. A command-line tool that launches the application client container and invokes the client application packaged in the application client jar file. Capture Schema. A command-line tool to extract schema information from a database, producing a schema file that Glassfish Server can use for container-managed persistence. Package App Client. A command-line tool to package the application client container libraries and jar files. Java DB Database. A copy of the Java DB server. XJACC. A command-line tool to transform, or bind, a source XML schema to a set of JAXP content classes in the Java programming language. Schemagen. A command-line tool to create a schema file for each namespace referenced in your Java classes. Import. A command-line tool to generate JAXP portable artifacts for a given WSDL file. After generation, these artifacts can be packaged in a WAR file with the WSDL and schema documents, along with the endpoint implementation, and then deployed. WSGEN. A command-line tool to read a web service endpoint class and generate all the required JAXP portable artifacts for web service deployment and invocation. Overview Java 2 E7